Get into it. So last time we talked about inheritance. We introduced this topic. Today, most of today is going to be one big memory diagram talking about inheritance. There's also a few little topics that I want to talk about before we get there. So inheritance, this is when we had one class that would borrow all of the state and behavior from another class. It would inherit all of the state variables and all of the behavior, all of the methods from another class. And we saw this diagram. This is the type hierarchy in Scala. And we saw that there were two major types that both extend this any, but any val, short for any value. These were all of the types. These are all of the types. Oh my goodness, come on. These are all the types that will go directly on the stack. The values will go directly on the stack. These are any value. So for example, a double, when we create a variable of type double, either on the stack or as a state variable in the heap, what's stored in that variable is that 64-bit value for the double directly. The value is going to be stored there. The value for the int, and we pretend that for this class at least that strings are in any val because they behave kind of strange. We actually used to talk about how strings worked in detail in 116, and we just never got the payoff from it. Like, there are cooler things that I want to show you instead of spending time talking about that and certain other topics. So we just pretend that they go on the stack as an any val, because ultimately that's how they behave anyway. They behave exactly that way. Just they get there in a more complex fashion. And then everything else extends any ref. So they get all of their state and behavior from any ref, and then they expand whatever they need to expand. This includes every single class that you write, every single class that I write, every single class you see on a quiz, on a homework. All of those are going to extend any ref if they don't extend something explicitly. So for example, we had a health potion that extended game object. So health potion extends game object, clear enough. Game object extends physics object, clear enough. But then physics object didn't extend anything. Not explicitly, at least. So if you don't explicitly extend anything, it implicitly extends any ref. So physics object extends any ref, and then we get all of the state and behavior of any ref, game object, and physics object and game object all inherited in the health potion class. So everything we write extends any ref, and the big thing to know about that is that those objects go on the heap. And then whenever we have a variable of any of those types, we actually only have a reference to that variable. Not the object itself, just a reference, any reference. So we only store references of those and pass references to methods, store references in variables, store references in state variables of object types, references. Let's clean up a topic. We talked about override briefly before, but I didn't go into too much detail of it, so let's talk about it. We saw override so far where we would inherit an abstract method and then use override to implement that method. That's the only time we've seen override so far. So let's expand our knowledge on this and talk about some other things. So one, we actually inherit state and behavior, or at least behavior. I don't think there's any state in them, from any and any ref. We actually get some things from them. So what do we get? Well, we get a decent amount of stuff, but the two things I want to highlight today, the two probably most useful, at least immediately useful to us as developers, are toString, the toString method, and the equals method. Whenever you call equal in Scala, you're actually calling the equals method, and equals and toString are both defined in the any class. And then their behaviors are overridden by the any ref class, which we'll talk about in a second. But these are defined in the any class, which means absolutely any value in Scala has a toString and an equals method. So absolutely everything eventually extends any. So everything has those methods. So you could take any two values in Scala. Doesn't matter what they are. It could be a health potion and a double. I don't care what they are. And say equal, equal. Are these two things equal? And it will call an equals method from whatever value you put first. It will call its equals method and use that to compare it with the other value. And most likely you'll get false if you're comparing two things of different types. Most of the time you're just going to get false. But you can compare any two objects of any types. Because equals is defined in the any method, and we'll see in a couple of slides that equals takes a reference of type any as one of its parameter. So you can compare any two values. Any ref overrides this functionality to give us some default behavior in any class that we write or objects of any type that we create. The default toString for any ref, which includes everything we write, including health potion, is going to print out or return the string, rather, object type, the @ symbol, and then a reference. When I ran this code to generate this slide, this is what I got from printing out a couple of health potions. I get the fully qualified, what we call a fully qualified class name. That includes package and the class name. And then at some random reference, just like the random numbers that I put on my slides. I usually stick with 3-digit numbers, but they don't have to be. Here we got a longer hex value. They actually use C's. I try to stick with just numbers in the slides. But same idea here. This represents where you can find this thing in memory. And we can see that health potion, potion 3 and potion 1 have the same exact reference because they refer to the same health potion. They refer to the same object on the heap. So we expect these numbers, I don't care what they are, but we expect them to be the same for potion 1 and potion 3. We care what they are relative to each other. Are they the same reference or are they not? So we got a different value for potion 2 because that potion's at a different location in memory. The default equal behavior that we inherit from any ref, which is I forgot one key point here. The println will call the toString method. So println takes anything and calls toString on it, and then whatever string is returned prints that to the screen. So potion 1, potion 2, potion 3, they're all getting their toString methods called implicitly through the println method. Then finally, equal. The default behavior that we get from any ref, that we inherited from any ref for equal is comparison of the references. So potion 1 equal potion 2 is saying, do these two references refer to the same object on the heap? And if we look at the code, we know that they don't. If we look at what's printed out, we know that they don't. They point to two different locations in memory. So this would be false. They don't refer to the same object. Potion 1, even though they have all of the same state, all of their state variables have the identical values. For all our purposes, these two health potions are identical, but they are different objects, different locations in memory. So false, not equal. Potion 1 and potion 3, these variables both store the same reference. They refer to the same object on the heap, so that'll return true. So this is behavior. These are methods that we get inherited from any ref that we have available in any object of a type defined by a class that we wrote. Absolutely everything has these, and this is the default behavior we get. It's not always super useful, though. If I want to print something to the screen, I usually don't care about its type because I probably already know the type by looking at my code, and I really don't care about the reference. In most cases, unless I really lost track of things, and I want to see if these two references actually do refer to the same thing, just like the equals method. It's not super useful to check if two things refer to the same object. So we can override these. We saw overriding of abstract methods. We overrode an abstract method. It had no definition, and we gave it a definition. But what override is saying is a little more powerful than that. It's saying, whatever definition I did inherit for this method, replace it with this definition. So I'm going to override toString. toString is a method called toString that returns a string, And another little Scala annoyance, I don't like this, but it's a Scala thing. Certain methods are defined without any parameter lists. So this is a method, but there's no parameter list. I would like to see an open paren, closed paren there to make it clear that this is a method. But if you do that, it won't override properly. It's a Scala thing. I don't like it, but it is what it is. There's some times where methods just no parameters. No parameter list, even. Like you're violating the syntax of a method definition, but it is what it is. So we're going to override it. We're going to say, for the toString method, a method named toString that returns a string that I inherited from one of my superclasses, whatever definition it has, which by default is print out the type and a reference, whatever definition it has, replace it with this definition. So when I print health potions to the screen, give me some actual useful information. Print me out the location and the volume of that health potion. Don't give me the name and the reference anymore. Then I'll override physics vector to get vectors in a format that I like, a comma-separated XYZ surrounded by parentheses. I'm used to seeing physics vectors like that. I don't want to see physics vector at 187E4. That doesn't help me at all. That doesn't help my debug process. So in your code, it can be useful. Like for project 2, it can be useful to override the item toString to actually print out the description and price of an item. Some useful information that can help you for debugging instead of printing out item at some random thing. That can really help your debug process, especially when you're printing out items in the hint text of your assert method calls in your testing. That can really help out instead of printing out some garbage to the screen. Give me the description and price of this object. My test failed, so I got something to debug. I have to debug something. Give me some useful information about that. Override the toString method and print the item to the screen, and that'll give you some useful information that can help you find where that bug is coming from. I got the learning objective, but not the application objective. Do I need to go to lab this week? I feel like I've answered this question 10 times in lecture, but no. Unless you need the interview. You can't get the application objective in this week of lab. Is there any way to check the reference number instead of running the code? No. A way to check the reference number without running the code. The reference number doesn't exist until you run the code. So when you create a new object, you're asking the JVM, which is asking the operating system, for memory. And we have no idea what memory we're going to get, what the current state of the JVM and the operating system are. We have no idea anything about that until the moment we ask for memory and they turn around and say, here's the memory that you're allowed to use for your program. And that's when we get the reference number. Reference number is the location of that memory. So until we run the program and ask the JVM for memory, we don't know what those reference numbers are going to be. So you do have to run it, and usually you have to run it in the debugger to see reference numbers. To get that information. Because they're just like I make them up for my slides, the JVM makes them up at runtime when you run your program. Not literally makes up, it's got an algorithm and everything, but you can't get them without creating objects. You need to run your code to create objects. I don't override or even define the method from the parent class. Do I default to the parent class's method? You don't override or define. If you don't define the method at all, and that's what we've done so far. The first time I showed you health potion, we didn't have an overridden toString. So if you don't have any of this, if I just delete this whole thing, I go back to the default AnyRef toString implementation. Reference numbers can be different every time you run your code. You might, just by pure chance, get the same reference numbers, especially if you run it 2 times back to back. The JVM might be using that same chunk of memory. If no other programs ran between 2 executions of your program, you might end up getting the same reference numbers. But it's only pure coincidence if you do. In all likelihood, they'll be different each time you run your program. What if I use parameter when I override some method? You mean state variables? If you use state variables inside your override, like this .location, it's perfectly fine. Oh, or unless you mean legit parameters. If you override this with parameters, it's a different method. you're not overriding toString. That's why, so the definition of toString doesn't have a parameter list, because we could define this with an empty parameter list, and that'd be fine. But it's already been defined without a parameter list, so when we override it, we have to exclude the parameter list. So it's one of those annoyances, like I don't even have the option to put an empty parameter list here, because I wouldn't be overriding the right method. It has to have the exact parameters and return type of the method and name of the method that you're overriding. If anything's off, if this is int, for example, it's not a valid override, and we're not going to see that when we print things to the screen. That would actually be an error if we had return type int. It'll say, error, the hell are you overriding? I can't find this thing. I can't find this toString method that returns an int. So I don't know what you're overriding. Would be the error you'd get. And the equals, a little bit more complicated. The one thing I will say is, in the homeworks and stuff, I don't really have a situation where overriding equals is super useful, but we use equal a lot. We call the equals method a lot, so I just want to show you the mechanics of how it does work when you call equals. So equals is a method that takes a reference to an object of type any, which means this method can be called with literally anything, any value in Scala, which is any object. All values are objects, so any object can be called. It has to return a Boolean. And then to check if these two things are equal, we need to do some type checking. So we actually, it doesn't help us to have a reference to something of type any. I actually want to know what type that the thing is that I called the equals method on. What am I being compared to? I want to know the type. So we're going to use this match case syntax, which I believe was asked about on Monday. So it's fun we get to talk about it now. I'm going to use the match statement, so this object, and I'm going to match to these cases, and I'm going to have a case for each type that object can be. This is the difference between, if you're familiar with switch statements, a switch statement and a match statement. Match can also do type checking for the thing that you're matching. So I'm going to say if this happens to be a health potion, if the type of object is health potion, then compare them by volume. So I'm going to say if two health potions have the same volume, I'm going to consider them to be equal to each other. If what I'm matching is not a health potion, I'm going to use Scala's wildcard, which we've seen a few times. For Scala test, we imported Scala test underscore to import everything from the library. This is going to say anything else. If it didn't match any previous cases, which is only one, which is health potion. So if it's not a health potion, just return false. I don't want people comparing a health potion and an int. It doesn't make sense to me, so I'm just going to return false. Those are not equal. So just return false. With those two overrides of toString and equals, this code has significantly different behavior. Same exact code, the only difference is inside the health potion class, we added those overrides. And now when we print potions to the screen, we're going to get their location and volume printed. No more references, no more meaningless values in our print statements. And when we compare with equal, that's calling the equals method, and it's going to compare by volume. So potion 1, do potion 1 and potion 2 have the same volume? Yep, true. Do potion 1 and potion 3 have the same volume? Well, they refer to the same exact potion, so I sure hope so. Unless something went really wrong, they're definitely going to have the same volume. Yeah. Yeah. Oh, do you mean in, like, do your double comparison with the epsilon? Yeah, like, oh boy, can you? So you can't change the definition of double because it's part of Scala. I want to say you could extend double and create like a my double class that extends double. But I don't think you can extend something that extends any val. I'm not 100% on that one. But you could create a wrapper, what we call a wrapper class, a class that has a double as a parameter in its constructor. So you create an object that has one value that's a double and then override its equal, and then compare those objects of that type. That's not getting quite as much as you want for it. There are really strange ways where you can override the double toString and actually modify the definition of double, but we generally don't like doing that because it breaks a lot of things. But I like that question. It would be nice to just have equal equal have that tolerance built in for doubles. Any other questions on overrides before we get into this thing? Any questions on overrides or anything else before we get into it? Do we need to override the toString method since we don't have one yet in our tests? Yeah, no, you don't have to. You said never mind, but just for anyone else wondering, you don't have to override toString. Like I said this for equals, but I think it's true for toString as well. I don't think I ever have a homework assignment where I'm like, you must override toString. Overriding toString is very useful, though, for your debug process. For when you're printing out your hint strings in your asserts, in your testing. And it's pretty useful. It's not super crazy useful because you can get the same information from the debugger. But if you want to save yourself a trip to the debugger, then it's very useful. Do we have to get rid of toString to check reference? Yeah, or use the debugger? Actually, I think the number in the debugger is slightly different than what you get with toString. But you don't really need to know what the references are. I'll qualify this with almost, but I've never cared. We don't care what the references are. We only care what they are relative to each other. So do these two references refer to the same object or not? That's the only level that we care about. So you could still use the equals method. Don't override equals and then use the equals method if that's something that you want to check. But usually you don't care about the actual value of the reference. So I keep saying that they're just made up. And we don't really care what they are. If they're the same for two references, then that's important to us because they refer to the same object. But that's about the extent of its usefulness. That would be the quickest way to check a reference. Just delete your override of toString and print it to the screen if you do want to see the reference. No more questions? We can go into memory diagram mode for the next 37 minutes-ish. What does object and object match? Object was the name of my parameter. Right here. So I can name this whatever I want. I chose obj, short for object, because object is a keyword, so I can't name it object. I have to change it a little bit. But it's literally any object. So I like that name. I think that's the name that Scala uses also. And I probably just got it from that. But that's just the name of the variable that I'm checking. So when you say equal equal, this is the calling object, and this is the parameter to the equals method. So if potion1 equal potion2, this would be a reference to the potion referred to by potion1, and object would be the same thing but for potion2 when equal is used. So I want to compare the first argument in the equal, or the first operand, I'll use that word, first operand of the equal operator, and then the second operand would be the parameter to the equals method. I think I used too many big words in that one, but I'm hoping that made sense. What is any? Any is the top of the type hierarchy. Everything, absolutely everything in Scala extends any. It's the top of the type hierarchy. It means that method can take anything as a parameter, or as an argument. Yeah, the any means it can be any type. Object is just what I name my variable because I don't have any information about that thing. All I know is it's an object because every value in Scala is an object. So I name it obj. Okay, let's start memory diagramming. So we start with the main method. We create a new dodgeball. This should be very familiar at this point. We've been doing this for a week and a half. Calling constructors, that gives us an object on the heap of that type. We're going to give it a random reference. It also calls the constructor method. So we get a call to this constructor method and puts that on the stack. We get a reference, this, which is a reference to the object that's being created. And all of the constructor parameters automatically become state variables. That much we've done so far. And sorry for I fiddled with this for a while trying to get this a little bit cleaner. I don't like that I have a variable name separated from its type like this. I wish the line break was right here, but I just couldn't get everything to fit exactly the way I wanted. So we do have to live with a little bit of a jank there, a little bit of messed up. But it is still valid Scala code. You can split up on lines like that. But we're going to call that constructor. It's a stack frame. We create the object in the heap. We separate the name and value for all the state variables, and all the constructor parameters become state variables. That we've done quite a bit. But the next step is going to be where inheritance kicks in. And inheritance is going to say, I got to step up the complexity here a little bit. So with inheritance, when we're extending or inheriting from, we can read extends as inherits from. As we're extending game object, when the dodgeball constructor is called, this is actually a call. Did I say game object there? Just in case I did. When we call the dodgeball constructor, this is actually going to call the game object constructor. We're going to get a new frame on the stack. It's going to get a reference to the object that's being created, and it's going to get its parameters, which also become state variables of the object that's being created. So when we have a superclass like this, when we extend a class or when we inherit from a class, we're going to call its constructor whenever this constructor is being called. So we called the dodgeball constructor with new. We call game object constructor without new, so we're not creating a new object here. We don't see the keyword new here, so no new object. But we are calling the constructor a new frame on the stack, getting a reference to the object that's being created, and all of its parameters become state variables. And guess what the game object constructor does? Well, it extends physics object, so this, again, is going to be another constructor call. We're calling a third constructor when we create our dodgeball object. We're only creating one object, but we ended up with 3 constructor calls because the dodgeball constructor calls the game object constructor, then the game object constructor calls the physics object constructor, and all of the state variables, all of the parameters for all of these constructors, all become state variables of the dodgeball object that's being created. Which is where that feature of Scala, in my opinion, gets a little annoying. How we have constructor parameters that automatically become state variables. It's not too big of a deal for just regular classes. That's usually what we want. But when it comes to inheritance, like, I don't want XY, XY, XY. I don't want all these duplicates of XY. A lot of the constructor parameters I have here are just like transient variables. I only have these variables here, so I can pass them to the game object constructor, which I only have here, so I can pass them to the physics object constructor. And then in physics object, that's the XY that I actually want to use, because that's what the physics engine is going to manipulate. The physics engine is going to mess with that X and Y. So I end up with 3 copies of those variables through the constructor calls. It's just the way Scala is. And this is why, not in this example, but a lot of my inheritance examples, I won't use val or var for any of the variables that I'm just using to pass those variables to a super constructor call. So I would delete var here, 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 and here if I only want to use the x and y from physics object, because I just want them called x and y. Those are the ones I'm going to use. So I would delete val or var just so I don't have to worry about accidentally using those x and y's. And this is why we're going to rename our variables. We're going to make sure we don't duplicate names. It would be absolutely valid to say var x, var y, var x, var y, var x, var y, instead of x object, y object, x dodgeball, y dodgeball. Instead of naming them like that, I could just name them all x, y, x, y, and have x, y, x, y, x, y. That would be valid syntax. It would be completely valid. And that's why we don't do that, because the scoping rules get crazy hard, really complex about which x and which y are going to be used at any point in time during my program. The scoping rules are strange with that one. Again, just like the putting strings on the stack, I got cooler things to show you. I want to talk about polymorphism and the state pattern. So we're just going to name these different things and not worry about those scoping rules. So when you call a constructor, you're not just calling that constructor, and you're not just calling that constructor and any constructor that it extends, of the class that it extends. You're calling every constructor in its entire type hierarchy. So we're starting at dodgeball. Whatever it extends, we're calling game objects constructor. It extends physics object, we're calling physics objects constructor. And since physics object doesn't explicitly extend anything, it implicitly extends any ref. So we're actually calling the any ref constructor, which is calling the any constructor as well. Just like our other cases like this, since those are part of the Scala library, we're not going to worry about them in our memory diagrams, but we actually do have two extra constructor calls that are going on the stack when we're creating these objects. We're not going to put them here. Any code that's not code that we can see isn't code we're going to put on our memory diagrams. It wouldn't be fair to give you a quiz where you have to memorize Scala internal code. I'm not going to do that to you. And it's not interesting to us either. It's not interesting to the run of this program. So we're not going to put those extra stack frames on the stack, which means physics object is done. So we're going to run any of the code at this point. We would run any code, not right there, any code that's outside of the methods. We don't have any in this example, but I just want to explain when it would be called. The code outside of the methods for physics object, execute, and any state variables that are declared out there will be added to the dodgeball object. Then that constructor returns. So this physics object constructor call just returned, so we're free to go to all of the code outside the methods in game object. Which again, none in this example, but this is when it would be executed. And then dodgeball, game object constructor returns, so we're free to run all the code outside the methods in the dodgeball class. There's no code out there, no extra state variables, nothing extra to do. So we just return that one as well. And this one finally returns our reference to our variable in the main method. And we get a reference to that new object in the main method. Any questions on that? So two things there. If I don't use val or var, they do still become state variables. I just have very limited access to them. I can't access them from outside the class, but they will still go on the heap. And if I don't want the duplication, I can just not pass them to the next constructor. I could call game object of 0, 0, for example, in this example, or set up my code in such a way that I don't need to keep passing them through constructors like this. The reason I have it set up for this example is the goal here would be, we're not going to build out the whole thing, but the goal would be to build a physics engine that works with physics objects. So I need a location inside physics object if my physics engine is going to be moving these objects around my game world. So I have to get the x and y to the physics object, and I only have access to the dodgeball constructor. So I need to get these values from my dodgeball constructor to the physics object constructor. So I'm going to pass them through all my constructor calls just to be able to get the x and y values down to my physics object. Alternatively, I could not declare these in the constructor. Like if I were to refactor the code to get rid of that, because it looks bad on a memory diagram, but it's not the worst thing to have in our code. But if I wanted to get rid of it, I would get these out of the constructor and declare them outside my methods, use my other method of creating state variables, and then in dodgeball, outside of the methods, I would say this dot x equals xdb, this dot y equals ydb, and I would get rid of my extra state variables. But I'd still have two. I would only cut out x object and y object that way. So it even wouldn't get me all the way there, but that's something I could do. Yeah, if you're really, when a project matures and you're worried about efficiency, yeah, it's something you would want to get rid of. You want to get rid of that feature. At this point, I'm just showing you that this is a feature, that this is how things would work. So I got a few questions in chat I'll answer, but I'm going to leave it up to you. Potion 1, when we create this health potion, what does it do? I recommend you write it out, but I know most of you might not want to or whatever, but at least think through how this health potion would work. And I'll give you time to think that. My next slide is the full of how that would happen. How do we know the values of game object when new dodgeball object is created? Game object has 2 variables. Dodgeball has 3 variables. Yeah, so dodgeball is taking 3 variables, and then I have access to those 3 variables when I call this constructor. So when I call the game object constructor, I'm taking xdb and ydb and using those as the arguments for the game object constructor call. So in the dodgeball constructor call, I'm looking at xdb negative 2.2, ydb 4.8, and I'm passing those as arguments to the game object constructor. So x object equals that negative 2.2, y object is that negative 4.8, because I use those right here. And this is a regular method call. I could do like xdb plus 7 if I wanted to do that. I don't have to just straight up pass those variables. If I want to do some scaling, if game object works on a different grid system than my game, I might want to switch things around like that. Probably not. I probably wouldn't want to do that in the constructor call, but it's something I have the ability to do in Scala. And then same thing with game object. It's passing these parameters as arguments into the next constructor call. I can modify them. I don't have to just pass them directly, but I did pass them directly, so x and y get the same values as x object, y object. And I didn't pass mass. I didn't do anything with the variable mass. So mass just didn't go into game object at all because I didn't explicitly send it to game object's constructor. Do we not do anything with toString in the memory diagram? Oh, we will. We will. These last 2 lines, we're going to do toString calls. Is object mass calling itself an object mass? This is in the toString method, calling object mass. I had to squish the code together to get the font big enough to make sure y'all could read it. So things get squished a little, but that's inside the toString method. All right, I just realized it's 2:40, so let's do this. So the health potion constructor is being called. That constructor is calling the game object constructor. The game object constructor is calling the physics object constructor. All 3 of them take all of their parameters and make them state variables in the object that's created. And all three of them have a reference to the object that's being created, and health potions constructor is going to return that reference into the main stack frame. What about potion 2? I'll only give you a little bit of time for this one. Are we going to get potion 2 working? Well, this is just an assignment by reference. Your key here, your thing to look for is, I don't see the keyword new at all here. If you don't see the keyword new, you're not creating a new object. No new object is created for potion 2. We're just making assignment by reference. So potion 2 equals potion 1. Potion 1 stores the value 200. We just literally look up what's the value next to that name. That's what a variable resolves to. It's OX200, so OX200 is assigned to potion 2. It's an assignment by reference. We didn't copy anything. We didn't create a new object. Nothing fancy happened. We just assigned that reference to the new variable, and that's it. No multiple constructor calls or any of that stuff. And then we've done some modifying state before, so I don't want to dwell on this too much, but let's at least change one state variable. Ball.x, ball 350.x, and increment it by 1. So we can change the state variables, and this is where we have to be a little careful in being aware that we have duplicate state variables like this. When we change x, that's an assignment by value. X is a double, which extends any val, so that variable just stores the value. So when x changes, it doesn't change x object, it doesn't change x dB. So if my physics engine is changing this xy, but somewhere else in the game I'm reading this xy, things are going to get out of sync, and that's usually bad. That's why I would hide these variables as much as I can by deleting the vars, so I don't accidentally access these other variables, and I just have my x and y being the ones that I use. They do change independently of each other, is the key point there. Then we're going to call object mass. This is where the other side of inheritance comes in. So the first side of it is when you call the constructor, when you create a new object, you're getting multiple constructor calls. You're going all the way up the type hierarchy, calling all of the constructors that are either explicitly or implicitly inherited by that type. The other side is what method is going to be called. So we did a little bit of this when we just had classes and we didn't have any inheritance. I had two classes with a method of the same name, and we said which one is going to be called. Same thing here, but it'll get a little bit trickier. So ball.objectMass, we have an object mass, ball dot, it's of type dodgeball, reference 350. So this is 350, and we're calling dodgeball object mass. We go into the dodgeball class, we find a method named object mass. It has the extra override here, but we're not too concerned. We found the method inside the dodgeball class. We're going to call it. Because the object, the calling object, that object at 350 happens to be of type dodgeball. We're basing what method is called based on the type of the calling object. Print 2 to the screen. This in the object mass stack frame, this dot mass 2.0. Potion 2 dot object mass, potion 2 dot, we found a health potion at 200. This is 200. We find object mass in the health potion class. So this is the method we're going to use. Put mass per volume on the stack frame and return this dot volume 6 times mass per volume 7, return 42 and print it to the screen. That much we've seen before. We have the extra override words there, but nothing too far from where we were. But now what happens when we call toString on a dodgeball? Things get a little more dicey here. So we're going to call toString on a dodgeball, and I'm doing this two different ways, by the way. The next line, I'm just print potion 1. That will implicitly call toString. I can either explicitly call it ball.toString or potion 1. When I print it to the screen, the toString will be called. So if you do see that on the quiz, that will be calling toString, If we have toString code here, you know that you have to look at toString and actually go into those stack frames if that code is visible to you on the quiz. So toString dot toString 350 dodgeball 350 dodgeball, but now we run into an issue. I don't see no toString method here. I don't see a toString method. Dodgeball, the class, does not have a toString method. So we use a similar search strategy as we did for our variable scoping rules. We're going to look up the type hierarchy, go to the class that it extends, and look there. That's our next stop. Game object, we're going to look for a toString method. Oh, good, we found one. Now, this is the method we're going to use. This is the method that's going to be called when we call toString from a dodgeball. If we didn't find it here, we would keep going up the type hierarchy until we did find it. But we did find one here. So this is what we're going to execute. And this method even calls another method. So we have the same question again. Object mass. What method do we use? Now we're not calling this from a dodgeball. We're calling it from a game object class. But we don't care about the class. We care about the object, the calling object. It's always the calling object. So this dot object mass in toString, this dot object mass, we found a dodgeball at 350. This is 350, and we use the dodgeball object mass. It goes by the calling object. What's defined in that object? Our methods return, concatenate the string, return, print to the screen. Print line potion 1, it's going to call the toString method, potion 1 dot toString. We found a health potion at 200. Where's my clock? At 2 minutes. Sorry. toString, this is 200. We called it from a health potion. Health potion, we did find a toString method. And the important part of this one is health potion did, this is the first time we're really overriding code where we can see both methods. Health potion did inherit some behavior for toString from game object. We can see it right here. Health potion had this toString method as its definition. But it said override that. I don't care what it is, override it and replace that whole thing with this definition. So we found toString in health potion and we stop our search. We don't call this method from health potion when toString is called. We only call this one. It calls, never makes it to the game object toString, never makes it to any ref toString, doesn't make it to any of that, just calls this and returns because it overrode any previous definitions. Above the lecture question anyway, but any questions on any of that? I can answer a few questions when the lecture question is up. I know the end of that went a little quick. I lost track of time a little bit. Yourself, I read those. Isn't toString already existing in the method? Would that cause conflict? No. So override says, whatever definition I have for this method, replace it with this new definition. So override is what's resolving that conflict. If we didn't have the word override, it would say, this method is already defined, you already inherited it from this other class, you can't have two toString definitions, you just can't do that. Once you say override, that's saying, I don't care about the other one, I want this one. Why object mass is called from class dodgeball? I mean, the why is because I knew it brought up an interesting question for lecture. But it's because it's called in the toString method. Why are we doing toString with potion? Did toString with potion because print line calls toString. Have a great day. I'll see you Friday.